Is Sai Kiran. I'm from ECB section. My topic is divided pulse nonlinear amplification. Introduction. High power and high energy transform limited pulses around 1.1 1.55 micro are needed for applications such as cataract surgery, frequency terahertz generation, and nonlinear spectroscopy. As common fiber lasers oscillators provide quite limited output powers. Air-dropped fibers amplifiers are widely used for power amplification. However, broad pedestal and pulse breaker typically occur in high power. To the interplays between cell-phase modulation and anomalous dispersion in the small fiber core. Therefore, the development of techniques to overcome the limitations on the transform limited pulse generation around 1 is still an active area. For DPA at 1.55 micron demonstrated the possibilities of divided pulse comparisons in co-adapted fiber amplifiers which delivered energy and time durations the help of 8 replica division. Reportedly a spatial and temporally DPA with an output pulse energy, but the pulse duration was measured to be longer than 600. An additional signal mode fiber had to be employed to further compress the pulse, generating pulse energy in duration. Furthermore, DPA's anomalous dispersion regime is still scientifically interesting because there are questions about the recombining efficiency when the significant nonlinear phase is accumulated in the comparison with a larger pulse comparison ratio. As for wavelength about 1.3 where laser pulses travel in an anomalous dispersion regime of optical fiber. Pulse amplification and comparison required initially for simultaneous plus pulse amplification and comparison in EDFS. A positively pre-cheaping seed pulse is desired through normal dispersion fiber. The initial pulse sitting from a mode local laser acquires a chip while its spectral shape remains unchanged if nonlinearity can be neglected. Such a pre-chipping can keep sufficient low peak power at the beginning of pulse amplification and thus helps to enough gain in order to study such nonlinear comparison of active fiber in anomalous dispersion regime. The generalized nonlinear Schrödinger equation with the split step Fourier method were used to stimulate pulse propagation, temporally duration and spectral width, and pulse energy was applied as the seed laser and a long activity fiber with group velocity and nonlinear coefficient performed the simulation. Simulation results it clearly shows that there are exists an equilibrium position which can not only restrict excessive nonlinear effects to ensure high quality temporal integrity but also produce sufficient optical nonlinearity to broaden the spectrum to support. A structured pulse fiber oscillator provides the seed plus with the repetition rate. A preamplifier was used to preliminary amplify and positively pre-chip the seed pulse to a duration. The pre-chirped plus was divided by hybrid divided and then was recombined with the help of reflecting pulses to pass through the same series. In the consideration of expensive price, optical quality and assemblability, crystals longer than 18 mm acted 24-25 divider. The system firstly operated with three basic dividers. The combined and uncombined powers at the corresponding output port A and port B are plotted along with the combining efficiency as a function of pump power. It clearly shows that the efficiency drops as the pump power increases with 8 replicas and combining efficiency starts at 99.5 and remains above 95%. in moderate and non-linear regime where pump power is less than 4 watts. Subsequently, the combined fraction gradually tends to be saturated and the uncombined fraction rapidly increase in over non-linearity regime where pump power is higher than 4 volts and the corresponding combining efficiency. Interestingly, in our experiment is the best value for the transform limited pulse generation. This is because of the transform limited replica is produced as a result interplays between the considerations of the nonlinear fixed and in such a way solution forms fixed value of net GVD in a double pass fiber amplifier. The energy per replica study increases and gradually approaches to the same value when the pump power increases. In other words, no matter how many replicas are generated, the energy per replica is fixed values in the identical nonlinear fiber amplifier. Shows the retrieved temporal and spectral intensities of the recombined pulse at this optimized pulse energy as shown in the insert. The measured the measured and retrieved frog patterns matched very well for different division. As predicted in previous simulation, replica reaches its starts pulse with one energy. The differential is energy probably comes from the between different types of fibers and the insertion loss of Faraday's law. Conclusion. In conclusion, we propose the polarization division multiplexing schemes. 32 replicas pre-chipped laser pulse were amplified to be the pulse and energy simulated simultaneously compressed duration corresponding to a peak power. Quantitative measurements and analysis of the combining efficiency for different number of replicas are discussed. Power scaling it is currently limited by thermal induced damage on optical fibers and fiber components. These are technically issues that can be resolved with carefully thermomechanical design as well as high power component. Therefore, higher pulse energy and average power can be expected. 128 replicas, 64 and 128 replicas are applied. Thank you.